Hello, eighth graders. My name is Mr. Harton from the CHESPAX program. In a little while, you'll meet Mrs. Subda and Mr. Wagner, and we're going to be working with you on an investigation of a local stream, uh, trying to find out the health of this environment. These streams are critical to a healthy Chesapeake Bay and a part of our natural ecology here in Calvert County. So what we'll be doing today is an investigation of the biodiversity of a local stream. Again, and this is important because you guys are probably either starting or in the middle of a unit in science class on biodiversity. And essentially, biodiversity is a measurement of the variety of living things within any particular ecosystem. So we could look at the biodiversity of a coral reef, the biodiversity of a rainforest, the biodiversity of the entire Chesapeake Bay. In this case, we'll be looking at the biodiversity of a very small stream, maybe like one that you might have in your backyard or somewhere within your own community. And what we'll essentially be doing is getting a measurement of the health of the stream based on the biodiversity that we find today. So our essential question for the day is, what did the insect biodiversity tell us about the health of our local stream? And when I say local, these streams came from somewhere near your school building. We tried to pick streams as close to the schools as we could to get a gauge of this. So what are these insects telling us about the health of this particular stream environment? And at the end of the day today, at the end of the activity, we should be able to come up with a score as to whether this stream is excellent, in fair shape, good shape, or poor shape. So one of the things we know is that rainfall is a big part of the story for our stream health. In years where we have extremely dry weather, we have a drought, the streams can actually dry up and there's virtually nothing living in them at all. In other years where we have extreme amounts of rainfall, maybe like a hurricane or a tropical storm, we get excessive amounts of erosion, and that can blanket the bottom of the stream with sediment. So, of course, that's where the bugs live, so that's not a good thing for those animals. So we want to see steady rain throughout the year is really ideal for our streams. Even in this short video, we can see the rain is beginning to puddle up in front of the CHESPAX office. There's a cement walkway. The rain can't make its way through that. It begins to pool up and it forms erosion around the edges of that path that you see right. So for our stream study, we'll use a technique that was developed through our own Maryland Department of Natural Resources. They're the folks that are in charge of monitoring and managing all the fish and wildlife in the state of Maryland, as well as public lands. And they know the importance of these stream environments, so they developed a system that's relatively easy for us to use to gauge the health of our streams. One of the things that we know is a lot of the insects that we investigate today are very sensitive to pollution. So if we start getting runoff from fertilizer or chemical pollution, it's going to have an impact on our streams. So the bugs are said to be pollution sensitive. One of the things that they're very much impacted by is the amount of oxygen available in the water, the so-called dissolved oxygen. So if there's not oxygen for them to breathe, or very little, those insects are not going to be able to survive. Temperature is another really critical factor. Here in southern Maryland, we're not so much affected by the lower end of the temperatures, but rather by real hot summers. So if our streams heat up too much, they can't support many living things. And then turbidity would be another example. If the water gets too murky, too cloudy, the bugs just can't survive. So one of the things that makes stream surveys really an excellent tool for managing the health of an environment is looking at, it's relatively easy to do, right? If you have a stream somewhere in your community that you can walk up to, place some of these leaf packs in there, or even just take a net and pull up some of the existing leaves in the stream, you can get a gauge of what types of insects are there and then use that information to grade that stream. We don't need any expensive scientific equipment or supplies or even an advanced degree to measure a stream. Just somebody with an interest and a willingness to learn a little bit about the bugs can do this. And the great thing about it is it's useful for a long-term monitoring project. We can take the data that you guys gathered today, we can compare it to what we found last year, or even 2 years ago, or 3 years ago, and then use the information we gather today and have that recorded, and then perhaps students next year or the year after will be looking back at your data to compare to what they found. So a long-term monitoring project is a great way to see changes in the health of our environment. So what we look for when we're selecting streams are streams about this size, not especially deep, not especially big. You can probably jump across a stream with one good jump. But look at all those leaves. That's the key to a healthy stream in southern Maryland. We're looking for a stream with lots of leaf material that serves as habitat for these insects and provides them with a source of food. That's the energy for the stream. So this is another one of our study sites down by Flag Ponds Nature Park near Lusby. This stream is a very nice stream. You can see those little riffles in the water. If you look closely at the picture, those little ripples, that's telling us that there's probably some oxygen being mixed into the water at those points. Notice all the shade. That's going to keep the temperature of the stream down to prevent it from getting too hot in the summertime. And of course, provides lots and lots of leaves for the bugs to use as habitat and as a food source. So this is one of our study sites after we've placed some leaf packs in there. See, we've got the bags totally submerged beneath the water surface. We have to tie them down because if we do get, say, a rainstorm or the water level begins to rise up, that could wash our leaf packs away. So we do secure them with some string. We also weight them down with stones to make sure they're near the bottom of the stream to provide the bugs with better access to them and keep them, below that water level. So that's typically how we set them up, and then we'll go back after about 7 to 10 days. That's normally the amount of time we want to leave them in the stream, and we'll collect them, and then we'll bring them in for our investigations. So here's a close-up of one of our leaf packs. This one's maybe a little bit higher out of the water than we might like, but it's in a good location otherwise. You see all those riffles around that bag. That's telling us that oxygenated water is getting through there. So if there are any bugs in that particular spot, they're going to want to use that little leaf pack that we have in that particular location. So this is the typical setup. And again, this is something you could do on your own. If you wanted an independent investigation, get some onion bags or something like that, fill them with leaves, submerge them in a stream, and in about a week you can go back and collect them and check them out. So we have some tools that we use, some pretty simple tools to conduct our stream survey. One of them is just a plastic box. We put all our leaf material into the box and add a little bit of water, and that becomes our source for our investigation. We use a little plastic ice cube tray as our sorting station. We'll add a little bit of water to that, and then that's where we put the bugs that we catch. And you're going to help us with that. You're going to help us find the insects today. We also use a laminated paper beneath our plastic box just to provide some contrast. These bugs are very well camouflaged for those dark leaves in the stream, and that white laminated page makes it easier for us to see the bugs. We use eyedroppers and plastic spoons so we can catch the bugs easily, but then return them back to the stream unharmed. We don't want to grab them with our hands if we can help it. We don't want to injure these insects. Everything goes back to the exact same spot where we collected it. We know they're an important part of our ecosystem. And then as far as identifying them, later on we'll pull out an identification key and then a rating sheet that we use to actually give the stream that grade that we're interested in. So here's our rating sheet that we'll be using today to get a gauge of the health of the stream. You can see there's 3 basic categories we'll be looking at today. Those bugs that are very sensitive to pollution, those ones that would be harmed if we had, runoff from a farm field or pollution from a factory or something, or even, salt, from when we salt our roads in the wintertime, can be harmful to those bugs. So if we find those, that's telling us that stream is probably in pretty good condition. Some of the bugs that are that larger category, these are bugs that can take a little bit of pollution, but not a tremendous amount. So if we find those bugs, it's probably a pretty good sign that the stream is okay. It's not too bad. And then finally, if all we find are these bugs in that right-hand category, that tolerant category, that's probably not a great sign for our stream. That means those are the bugs that can handle lots of pollution, and if we don't find any of the others, that's probably telling us a pretty negative story about this stream. So what I'd like to do is show you a very short, about a 2-minute video clip just giving you guys an idea of some of the types of bugs we might see. So we want to return now to our essential question for today, and that's, what does the biodiversity of these stream organisms tell us about the health of this local stream ecosystem? So what we'll do in just a moment is we'll take a look at our insects, we'll sort them out, we'll capture them and sort them, identify them, and then we'll use that rating sheet to actually get a grade for the health of the stream, and then we'll make some final discussions about what is the stream telling us? What is the story that it's telling us about its health based on its biodiversity?